All right, for those of you who are just joining us, we are just starting to go live, trying to figure out how this. It's been a year since almost a year since I've done this, so just wanted to say welcome, and we've got the chat running. Um, so this is just a kind of a live stream. I don't know how many people we're going to have, but I just wanted to bring everybody up to speed. I want to welcome my guest, David Bedard, and
Hello.
I want to make sure for those of you who are in chat, who are listening, and who are there, can you hear us?
It does. I'm looking at the live stream on YouTube, and
Yep.
it doesn't look like there's any video.
Oh,
Oh, there it is. There's a delay. How much of a delay should there be, John?
There will be a little bit of delay inevitably. So don't worry too much about it, because what you're getting is it records with us, and then it goes out. So we are utilizing Zoom, so there is going to be some degree of technical issues. Good audio, video is working. That is always
Very
really good. So again, I just wanted to start welcoming people as we have people arriving, and I have a very special guest in David Bedard, and so David, I think what we're going to do is just start with a little bit of an introduction to who you are, your role in terms of model railroading, how long you've done it. I'll do a little bit of an introduction. Is that David lives, and you're originally from Calgary, right?
Yeah.
Yeah. So David and I are born and raised in Calgary, although I'm now living in Nanaimo, British Columbia. So we are doing this in distantly, and so David, how long have you been doing model railroading in general?
Well, I'm 46 this year, so 40 years or so. Young child, woke up on my birthday to a big stack of nicely wrapped boxes, and been hooked ever since.
Mm-hmm. And we are looking at that is your layout room in behind you.
Yeah.
So
it's a whole mess right now, but yeah, it's sure is.
Well, and it's very much in progress. So you are modeling the CP rail, Revelstoke up through Glacier National Park.
That's right.
Okay.
That's right. Yeah.
Okay. And of course, Revelstoke being one of the central areas when the Canadian Pacific Railway was built. They actually still have a turntable there, do they not?
I think it was taken out.
Okay.
I did the physical spaces there. I think the turntable's gone.
Yeah, and so it's just on the Revelstoke is the west side of the Rogers Pass, and some of the steepest railroading in North America, at least at one point before they started putting tunnels underneath mountains.
Yes, right. Yeah.
So, anyway, David, but as much as we would love to talk and see about your layout, and this will dovetail into it, you're here because of all the people that I'm aware of in terms of who've been doing 3D printing. I've seen some of the stuff that you have on some of the Facebook forums, but also through our common connections in Calgary. About the work that you've been doing with 3D printing. And I mean, I put out a video a week ago. I am brand new to this. And for me, it's still in the gee whiz phase. And it's sort of like the Dunning-Kruger effect is that being overconfident in what I know, and I'm getting to the point of how much I don't know, because I'm learning what I don't know. Or learning that I don't know a whole lot of stuff.
Yeah.
And so part of this is just we're going to talk about the stuff that you do, the potential for 3D printing for model railroading, And just a general catch-all, because he's going to be doing some live demonstrations of designs and showing, like watching him work is just amazing. So we're going to be doing a lot of that. Also, this is Murphy's Law. Any live broadcast, something can and will go wrong. It will go wrong. I expect the other half of my family to come piling in the door at any moment. And my son is out there, and he could just kind of explode in the door, and he's louder than power tools. So just be aware that could happen. So that's just a general disclaimer out to everybody. So I guess, David, when did you start 3D printing?
Well, I will go back to the genesis of my 3D printing journey. It was not last summer, the summer before, the summer of 2019. I was on Hornby Island, and my friend Jeff Briggs, were talking about 3D kits. He came out with a kit for Kato SD40s, and he confided he wanted to know what to put in the kit. So I said, make it as comprehensive as possible.
Right.
Anyway, so he sent me some of these kits, and I tried them out. They were awesome. And so I'm on Hornby Island, and he lives in Victoria. And I was on the beach, in a chair with my cell phone talking to Jeff, and Jeff's like, dude, you should get a printer. What? Get a printer. What do you mean get a printer? You're a smart guy. You could probably print your own stuff. Okay. We're talking like thousands of bucks, right? They're like, no, about $300, $350, whatever. All right. So got home to Calgary, ordered a printer. It arrived a few days later. And the wife is in oil and gas. She's been using CAD for a long time, and she taught me how to start with CAD. And I started printing signal kits, paid for the printer within a few weeks, and went from signal kits to plows, from plows to whatever. Yeah. Right? So I'm really at a point now where I've learned the MSLA resin printer stuff, and now I'm moving to the FDM stuff. Right. And I'm trying to combine these two different mediums, because they are different in model railroading. And I'm having a whole lot of failures and some successes. And the success is really, it makes it worthwhile, because once something prints, if you want 100 of them, it's a matter of slicing 100 of the same thing and printing them off. Yep. Well, oh, look at that. Yep. The just 40-foot containers. Shipping containers. Yeah. In N scale, and I can print 7 at a time. And that's have crazy. That. And this is something that you can do in design. So just now, what would that cost you per container in N scale? If you were to go to buy it. If I were to buy it, they would be anywhere from 10 to, I think in pairs, somewhere around $15 to $20. So about $7.50 to $10 each. Yeah, give or take. It depends on the make and the manufacturer, but they can be more than that. Now, what does Chitubox say that costs you to print? I think the last time I checked, printing this off was probably about, I would say, how much would that be? Don't be conservative. Okay, being a little bit more generous in that, probably maybe 75 cents for all 4 of these, or all 7 of these. Is somewhere in that way in the resin itself, and because I actually have a file that actually works for this. This is the second batch that I've printed, and I've got another 7 downstairs, and I could, because this is a solid, successful way of printing a bunch of them. I've got this file, and I can just go downstairs and just hit print again, and a few hours later, I've got 7 more. Now I have to paint them. But painting is one of the things that I like doing, so that's not an issue at all. So so I'm at the point now where I try not to buy detail parts. I try not to. If I can make it, if I can design it, if I can print it, don't need to buy it.
Okay.
Right? That's the trick for me, right? It's
okay. So do you want to do a little bit of show and tell? And to everybody who's watching in chat, feel free, ask any question you like at any time. Generally, there's a philosophy that I pursue is that there's no such thing as a stupid question, and there's never a bad time to ask it. We may not be able to get to it right away, but just simply put the questions that you have into chat, and we'll try and answer it. I mean, David is the real guru here as far as today is concerned. I have some limited experience with it because I have both a filament or FDM printer and a MSLA or resin printer. Actually, David, just before you do that, can you explain the difference between the two?
simply or
Simple, very simple.
FDM uses a nozzle to heat up plastic, and it lays down that plastic in a predetermined pattern, one line at a time. MSOA uses a resin that hardens at a certain UV wavelength, combined with an LCD mask and a build plate to build up your items one layer at a time, rather than the outline and fill it in. So they're two completely different technologies.
Mm-hmm. And because they're different technologies, they actually require very different approaches. Like, actually, I do have a quick demonstration. And right here, one of these, namely this one here, is filament or FDM. And this came off the printer today, finally successful, resin print. And then I also have a black one, also in filament. But on the other hand, I do have an unsuccessful print here as well. But that's another story.
Lots of those.
Oh yeah, lots of
those.
Lots of be used to failure. Now and actually one of our viewers is Eric Hall from Arizona of IMRRO. IMRRO, basically the Institute of Model Railroading Operations, I think is the is that, and so you were saying, there's Marcel. Hi Marcel. The Cloverdale Rails Marcel Verleur. And here's a good question, David.
Yeah.
Can FDM be used for N scale, or is that where resin is needed?
FDM and MSLA. They're for different purposes. Think about FDM printers for structural things like a turntable, a station, a throttle pocket, anything that doesn't have any detail, but you require structure. Resin printers, MSLA, that's for the fine detail, right? So if you wanted to buy a printer for N scale or HO or O scale, and you want it for details, look at an MSLA printer. I wouldn't go with an FDM printer. If you want detail, you have to go MSLA. It's my opinion, but we can go, and I can show you the same file sliced in for FDM and MSLA, and you can see why there's a difference. Does that answer the question? Right. You got to go MSLA if you want detail.
Yeah. So basically, short answer: structure for FDM and structure and utility, I think, for FDM, and detail. Yes. Like for example, here's another example of in progress. These are a universal paint holder prototype that I'm working on. I actually have the full size one printing downstairs. It took 19 hours, and unfortunately, I started the 19 hours about 17 hours ago.
Yeah.
So it's not quite quite there. So okay, good, Barry. That answers your question. Now, while Dave, while you're doing a little bit of show and tell, one of the things that I'm going to try and do is Eric Hall actually sent me a couple of pictures of. He's got some IBC chemical totes, pallets, 5-gallon buckets. He actually sent me a picture of those just ahead of the broadcast. So if you're interested, like I think people might find this interesting. This is stuff that Eric has done, and I think the beauty about this is that when it comes to this, if you have a printer. Of your own, and somebody else designs a file, there's no need to ship it across mail. You email it. For example, we'll talk a little bit about this, but I printed this today. It's the front end of a snowplow that David designed, and this is an N scale. He designed it in H.
Can you hold that up there, John?
Sure.
So you're the first one with the Eastern N-scale plow. I haven't printed those off personally.
Okay.
So all I did was take the HO file,
right,
and shrink it down, and you were able to print it.
Yes. So that one printed fine. Now, some other elements of it, just because I'm still getting used to the printer, didn't at least on first blush didn't work. But I was getting a little ambitious. I threw everything on the plate and hit print.
Why not?
And so that works it. So now, actually, just so everybody knows, what kind of printers do you have collectively?
I have 2 elegoo Mars.
Mm-hmm.
These are the standard ones. You can get them for 260 Canadian bucks.
Mm-hmm.
And then the Sunlu S8, which is about $300 Canadian.
And that's your FDM.
No, they're definitely budget printers. There's nothing high end about these things, but the elegoo MSLA printers, the elegoo Mars, their support is really good. Like, I had a couple parts that were no good from opening up the box, and within a week I had them from China. So I love the elegoo stuff.
Perfect.
But when it comes to FDM, I'm really new with the FDM.
Yeah, and I believe Eric. By the way, Eric, for those of you who are watching, Eric also happens to be one of my moderators. So he kind of keeps everybody in line. But that little blue wrench. So, and I believe, Eric, you have an any cubic photon, right? Is it, anyway, I'll watch for the reply in the chat. So. David, I'm going to throw you up to full screen. If you want to do a little bit of show and tell with all the different cameras you've set up, and while I'm trying to dig up one of Eric's pictures, and then we may move to doing some screen sharing. So now Eric has just made a point. Eric is like me; he's an N scaler, but he models everything in HO and then shrinks it down. Yeah. So. Yeah. All right. So anyway, let me just switch this off so that now it's to speaker view. And so, David, you are now big screen. And
hey guys.
And so that's just I'm just in the top, and David's below me here. So I'm gonna go just dig up those pictures so I've got them on hand so I can share them. And I just realized, David, if you are going to share anything. That I need to make it so you can share your screen. So now you can.
Sweet.
Yeah. So
you want me to show them what?
You know what? Do the little show and tell with some of the stuff. You got a brand new camera today, so you may as well start with that.
Okay, I'll do that.
Yeah. Okay, there are some other questions kind of coming up in chat that I'll relay. But anyway, you go ahead. I'll try and I want to bring up those pictures from Eric, and we will go from there.
All right, so I got it's an Intermountain FP9, and this is a winterization patch. It's hard to see because my picture is really small on my screen, but that's 3D printed. Let's go for the big guy here. This guy here. So this is a CPR open observation. I think they had 3 of them. But he's got one lone occupant. I don't know if you can see him in there. Do you see Bernie? Bernie Sanders is sitting in this thing. Nice cold Bernie Sanders. But because of the size of the elegoo Mars, I had to print the sides in 3 pieces. Hide the butt joints with rivets. The roof is printed in 3 pieces, as well as the floor. But I was able to, all the chairs are keyed in, so you have the right amount of chairs, and underbody details are, with the information I had, I did the brake rigging, and these are Rivarossi trucks. Mm-hmm. So that's what's possible with 3D printing, I guess. It's really, it's your imagination. Here we got lots of Bernies. Mm-hmm. There's 6 Bernies going on there. If you need some tanks, there's some propane tanks mm-hmm. for welding and whatnot. Here's the front end of a Cpr Prairie Plow.
Okay, so that unlike the one that you have me, you said you sent me the front of the, and of course that's a HO scale as opposed to the little N scale one that I've got in front of me.
That's right, yeah. Mm. And here's a more different Western plow. It's got a different mm-hmm. top to it.
So how many different?
I don't know if it shows up. Can you see the rivet work on the blades?
Yeah, I can.
Does that show up?
I can see the rivet work. Oh, there's Andrew says hi.
Andy.
Now I can see the rivet detail. Can everybody else out there see the rivet detail? Just it always takes a little bit for the chat to show it. But now you can tell we're Canadian because we're dealing with stuff that deals with a whole lot of snow.
Yes.
Well, although admittedly, being out here on the island is that snow isn't so much a thing, at least where I am. So,
wow.
And my sympathies on the weather, David. By the way.
Oh, that's all right. It's fine.
Mm-hmm.
It's snowed. It's cold, but it's sunny out. So, yeah. Well, it's dark now, but
yeah. Mm.
Here's how something comes off the printer.
Okay.
This is 1/2 to a water tank off of an FP unit.
Okay. Yeah.
Right, so you need 2 of these to make the water tank, and this is keyed for the Intermountain. It's something you couldn't really buy before other than miniatures by Eric. Mm-hmm. And now you're able to kind of make your own parts, right?
Well, and the neat thing about the detailed parts is you're able to do that. In fact, I've got those pictures from Eric. So just after this one, I'm going to quickly pop over, show some of the what Eric is, and then we'll come back.
Oh, sure.
So hang on just a second. I've got to move into Zoom. I'm going to make sure that I'm sharing the right screen. Here we go. Okay, and
oh, look at that.
Yeah. So there's the design that Eric did, and then those ice containers. Now, Eric, I assume that I'm assuming you made your own decals for that. And now I didn't see if you just sent me this design, and some of that's Eric. That's one of yours, but I'm not entirely if you can let us know what that piece is in the wild hair box, and then we also have these.
Cool.
Yeah, just the detail on this is just astounding, because I mean you can kind of get an idea of the scale by the paper towel that it's sitting on top of.
No, those are really clean. What I do is I look at the edges on the hinges.
Yeah.
If they're sharp, that means that printer's dialed right in.
That's a really good print.
Very nice. Yeah.
Very nice, Eric. Thank you very much for sharing those. I'm gonna just quickly stop the share, at least on my end. Got it. I've got a dozen different windows open here to make sure that that chat. Okay. Oh, they couldn't see the screen. Oh no, hang on. Let me go back. Let me try that again. Okay, so let's try this again. Okay.
Screen was blank.
It was blank. Oh, lovely. Okay. And it still appears to be blank. Oh, this is annoying. Oh. Can you see them? I appear to be frozen. Oh, lovely. Now, can you hear me?
Yes, I can hear you just fine.
Okay, because I am frozen to everybody out there. I'm gonna transition back, transition forward. Let's see if I can get this to work. Okay, I'm gonna stop the share and see if I think Zoom and OBS don't want to cooperate very well. Okay. All right, so my screen sharing didn't work. Just in case, David, let's do just a little technical test.
Yeah.
Are we back to moving?
No. Okay. No, it doesn't look like it.
Okay, so you can hear.
Oh, I think we're back now.
Okay. All right. Okay. That's a little frustrating. Okay. I'm gonna have to try and maybe do this a different way. David, just in case, do you want to try sharing your screen, see what happens on our end?
Sure.
We might have overloaded the pipe. Because if not, we might be just relying on your. So, all right.
Can you see this?
All right. Let me just pop out of this and go back to OBS and see if I think OBS is seeing part of it, but not all of it. There we go. There we go. I think we can see that. It's going to be a little slow, I think. Okay. So, can everybody see David's shared screen? It seems to be partial. Because we were getting it with your window. Remember how I said Murphy's Law here and Murphy's Law of Technology?
Yeah.
So for whatever reason, David, I'm only getting just a couple chunks of what I mean. It pops up periodically, and then it kind of disappears. So, do
you think it's my pipe or your pipe?
It may be our respective pipes. So, okay. Do you want to now? Are you sharing the just this app, or are you sharing the desktop?
Oh, just this one.
Try sharing your desktop and see if that's any more effective.
Okay, try that.
Okay, so we're trying this. We did a test drive on this yesterday, and it all seemed to work, but it
won't let me share my desktop.
Okay. Mm-hmm.
Do you see my desktop?
Yeah, I see your desktop now.
Okay.
So
you are screen sharing.
Okay. So let's try this out.
I'm waiting for the YouTube to catch up here.
Yeah. And there's Chitterbox. Can everybody see that? I think we're in better shape. So
yeah, YouTube is about a minute behind us.
Okay.
Yeah. So.
All right. So
being patient here.
Hopefully we've got this here. once everybody catches up. So, David, what are we looking?
It seems to be okay, John. I'm looking at the YouTube video after the fact. It's a little choppy, but it's okay.
Yeah. Okay.
Okay.
Looks like people can see it. So I'm just keeping an eye on the chat. Anything goes sideways, let us know. So
what we have here is a GMD SD40 Pilot.
Okay.
This is keyed for a Kato SD40.
Mm-hmm.
And you can see the support structure.
Okay.
Holes for MU hoses, for dimples for the uncoupling lever, holes for the handrails.
Mm-hmm.
Right here you have a MU connector receptacle. Okay. And then a doohickey on this side.
Mm-hmm.
Right? Yeah, so this is, usually I print them in pairs.
Yep.
And usually with a rock pilot. So,
okay.
Did you see the rock pilot here?
Yes, we can. Actually, I think sharing the desktop actually worked reasonably well because
it's a little better.
Well, so it's not flipping out on all sorts of different windows. Now, what I'm seeing there, Dave, you add supports in CAD, but you also what's clear, you've also added supports into that file with Chitterbox itself.
Yes.
Okay.
Yeah, so if you look at the vertical supports, they're straight cylinders, right?
Yeah.
So that's added in CAD, right? So you have a plate on the bottom, and then you got these verticals. The one thing CAD's not very good at is generating these supports that come off at an angle. Mm. So these angle supports, I can put them in Chitterbox because they generate quite easily. Okay. Yeah, so that's why that's kind of
now for people who aren't for people who aren't familiar with 3D printing, with resin, why are supports necessary?
Two things. It separates the part from the build process, right? Mm-hmm. So it's like a sprue in a plastic model. You've got a place to actually cut it off nice and clean and file it down. And also supports work to stabilize the part while it's printing, which is critical because you want it to be straight and true and whatnot. So, yeah. So if you look at these steps, for example, let me remove two of them so we can take a look. These supports have different functions. So these supports underneath the steps, they're initially supporting the bottom tread. Mm-hmm. You can see the bottom tread, and that supports the bottom tread. Yeah. And then from the bottom tread, the print actually builds off of itself. And I'll show you how that works here. We're going to do a quick slice. Mm-hmm. And, so we're going to go to the bottom tread there. Mm-hmm. So you got the supports come up first. Mm-hmm. And then you got the bottom of the tread. You can see it forming in the foreground.
Right.
And you can see how it builds one layer at a time.
Yep.
And this tread is actually building off of itself. Mm-hmm. Right? And then these supports show up to support this overhang right here.
Right.
So their job is to support this. Now, this vertical support on the back, that's for stabilization. Because if you see, I don't actually need it specifically for the steps. They're gonna build off themselves. There's no problem there.
Yeah.
However, the farther the print gets away from the build plate, the more floppy it is in the resin, if you will. Mm-hmm. Right? So you need these. So we don't need them, but if you want a square print, you want these vertical supports. And their job is just to hold everything in place. Because now you've got a nice long kind of base all the way up. And when this print, it'll be nice and straight.
Good.
And that holds true with the back. You can see we've got these 90-degree angles here for stabilization on the back. Just like that. Mm-hmm. And they don't go all the way up, just until, the print's almost finished. And, so after this is done printing, you would cut off all these little supports you don't need, and you print a little bit of filing, and your print is done.
Mm-hmm.
Does that make sense?
Yeah.
I hope that makes sense.
Yeah. And I noticed that actually for let's see where the piece the MU piece on the front that's at the top, there's a long support that comes up to that.
So if I didn't have that piece, the little chin of the MU connector. So the support is only there to support this little chin. Right there. That's it. Just that connection right there. That's all its job is. And once this is formed, technically you don't need the support, but it comes out.
Yeah, but it's there anyway. So
there, because after that it just built off of itself.
Good.
Right?
Okay.
Does that make sense? But these little overhangs here, see if I can do this. Little overhang over top of these MU holes.
Right.
Notice I got a little radius.
Right.
That wouldn't exist on the prototype. Now that radius is there because you're going to print this layer, then this layer, and it's just a little tiny overhang, right? Now if I had a right angle there, this big overhang probably wouldn't print.
Yeah.
So really this overhang is only, this long. It's not all the way to the... So it's a little bit of a cheat.
Yep.
I'll do that once in a while, but it's something to think about when you're designing for 3D printing.
Now, David, I'm just... I think we're clear on questions at the moment. Did you want to go back? Okay, I mean you've done some of your show and tell. I guess part of it with getting into this in terms of the detail. People, anybody who's listening in, toss out whatever questions you have. Some of this we can get it advanced or as basic as you need to be. And so say for example, someone is just getting into 3D printing. Shall we try and do a live design? Like say for example, an oil barrel.
A what?
An oil. Someone wants to make an oil barrel.
An oil drum thing.
Yeah, an oil drum. Well, 55 gallon drum. I have actually watched Dave design in real time. Now you're using AutoCAD because it kind of, at least in terms of the connections, your wife she's in oil and gas. She taught you, so it's available to you. Similar programs, of course. SketchUp is free online, but it doesn't have as many necessary bells and whistles. I know that a few people have been talking about Tinkercad is another one for designing, and Fusion 360 is free if you don't make money off of it, and you got to sign up for the free every year. The limit of my experience right now is simply SketchUp, and there are things that you can do. For example, rivets that are much harder to do in say SketchUp, but are much easier to do in what you're doing.
Yeah. So I can open up CAD here.
All right.
Do you want me to do like a demo on rivets and windows real quick, and then come back and do an oil drum?
Yeah, that'll be great. Now, quick. There is a question that just came out. How thick do you make the printing pad and first layers on the print?
My rafts, 1.5 mil.
Okay, 1.5 millimeters.
Yeah.
Okay.
Yeah.
All right.
That's 1.5 mil. That's what I use. Some people go thinner.
Yeah.
With an MSLA printer, if when you print, right? So you have your build plate and it goes down and you level your bed. Now that build plate is going to push into the FEP just a little bit. So your first couple layers are going to be pushed out.
Yeah.
They're called elephant feet, right? So if your raft is bigger than those first initial layers, and anything printed after that won't be squished up.
Right.
So you can make your raft 2 mil. You can make it a 1/2 mil if you feel lucky. I find 1.5 mil just means that my leveling can be forgiving and I still have successful prints.
Okay.
That's why I chose 1.5 mil. It also is my go-to thickness for passenger car size, and but if I got a wall, 1.5 mil is a good trade-off.
Okay.
So.
Yeah, and so like I gather that generally you wouldn't go necessarily any thinner than 1.5 millimeters. So
no,
okay.
Not really. Sometimes you have to.
Okay.
That's a 31 mil. Okay.
And now,
all right.
And I just had somebody else just make a comment. FreeCAD. I mean, there are a number of options that are out there that I think are really useful with that. Just hang on for a second. I realized that. Every time I switch windows, I have to everything's sort of popped around, and I have to make sure I know which one I'm in. So curiously enough, I'm going to have to try and find a way because for whatever reason my screen didn't share. I'm going to have to actually, Dave, while you're getting set up, I'm going to try and run Eric's pictures again. So
can you actually see? Oh, they're watching my cat, right?
Yeah, they are. So no, they everybody can see that. So actually, you know what? I'll show Eric's stuff after this. So go for it.
All right. So if you want to narrate.
Okay. So now I'm just sort of watching what David is doing. Is that essentially you're basically doing the equivalent of a side of a passenger car, correct?
Yeah, we're just going to mock something. We're going to make something up on the spot.
Yep. So basically, a passenger car with windows, and of course, your era is 1974 or 1950s, depending. Am I correct?
Yeah.
Okay. And of course, one of the things one of the things on the plow is just the amount of rivet detail that are in there. And because I do modern, I love rivets, but I don't really do, but my era is sort of the post-rivet era. But I was really impressed with how quickly David was able to kind of show how things like making rivets in this and in a way that will, when you design it, we'll be able to print them, and it's an embedded sphere, and you just duplicate however many you need, and just add them, and they're just the sphere is just embedded in the surface of it. Now, how thick is the wall that you have there?
This wall is should be 1.5 mil.
Okay, so. Yeah.
It'll show up here in a sec. Yeah, 1.5 mil.
Yeah. And
this panel here is 0.15 mil, which I find is the minimum to actually show up in a print.
Right.
Let's go like this. Sorry. I'm working faster than my computer can keep up.
Right.
Copy.
Yeah. Okay, and you
just make a few rivets.
You've just made a bunch, and now you've got something that you can just take the amount of rivets that you've done and now extend it, and it will evenly space them across.
Yes, I just used the fit command.
Yep.
Can you fix this?
So.
Oh, you're a kid.
Yep. No, he just handed me a broken toy and wants me to fix it.
Well, you can't do that now.
No. It's a busted slinky.
So,
yeah.
Those are important.
Yeah. Now, here's the thing. Of course, you're working in metric. Do you find that generally working in metric is easier with this kind of with 3D printing, or do you think it really matters?
Well, I'm Canadian, eh?
Yeah. Well, I mean that goes without saying. I mean, I work in millimeters too, as far as this is concerned. But so I mean, everybody is seeing this. I mean, he's designing this real time, and what he's doing here is something that can actually be 3D printed very easily. So the idea is, if you want to, if you have an ambition on making something like I guess one of the questions is specifically why 3D printing? What are some of the benefits to 3D printing and model railroading? Just while you're working on this, because
is that a question to me?
Yeah. How would you answer that, David?
Because I'm self-sufficient and I don't like waiting for companies to make my toys for me.
Yes, I think that's it. That's it.
I don't know what else to say, right?
Yeah.
It's, I don't have to wait for Bowser to come out with an SD40.
Right.
I just make my own.
Right. And
right. So.
And something like, say for example, because of course on your prototype you're doing Revelstoke to Glacier National Park, that you're able to custom design things down to the rivet.
Yeah, but I don't want to be accused of being a rivet counter.
Yeah.
Yeah. That's the difference, right?
Yeah.
Because some people look at it as a negative.
Mm-hmm.
Right? And I do count rivets, but to the point where I care.
Yeah. Yeah. And
I'm not doing it to impress other people. I'm doing it because if I've got the prototype picture in front of me, it takes me 3 seconds to count the number of rivets that are there.
Right.
Yeah.
Yeah. Mm.
There's no one's got any questions of what I'm doing, eh?
Yeah. So can everybody see what David's doing?
They can see it. I got the YouTube open up.
Yeah, and so you see all these kind of rounded, these rounded block shapes. So why did you do that, David?
Well, I got the wall here.
Yep.
This is our pretend passenger car, and those are going to be. I'm going to use the subtract command, and that'll take your basic wall shape and subtract these basic window shapes, and then you leave holes for windows. Okay, that's the goal.
Let's see this happen.
All right, so we're going to go select the body side for subtract, and then it's going to ask me what do you want to subtract, and we're going to select all the windows, and then 1, 2, 3, whoa, it's gone.
Bang, and all of a sudden you've got a bunch of rounded edge windows.
Yeah.
And of course that will print.
Hopefully.
Yeah. And the nice thing is you've got those lines of rivets, and you just kind of copy them over. And
so what I'm going to do is these lines of rivets should surround the windows in my world.
Yep.
So we're actually going to apply it. Come on, copy. Sometimes the clicks aren't working because the CPU is working overtime here.
Yeah.
Oh, I see what's going on. Never mind. It's my bad.
All right. Yeah.
No, let's undo that one.
Now, if someone is just learning how to do CAD, is there any particular flow and pattern that you would suggest to someone who's just at the base of the mountain of the learning curve?
Start with something simple. Obviously, keep going until you hit a brick wall, and then go on YouTube and type in how do you copy paste it? How do you copy items in CAD? And then it'll tell you, and then you'll practice.
Right.
And move farther until you hit another brick wall, and then you get the idea.
Yeah.
It's a matter of.
So the the idea is that like you don't recommend people start with a passenger car. You like have them do like an outhouse or a hot box detector or something like that.
Yeah, something simple.
Yeah.
Yeah.
So
get your feet wet.
Yep.
Well, I made that a little big.
Mm-hmm.
It's supposed to be just a letterboard.
Mm-hmm.
Pretty big, whatever.
Mm-hmm.
So there we go. We got a passenger car. What else should I do this passenger car sighting?
Should we have a door?
Oh, we don't.
No, we don't have a door.
No, so I'm gonna make a door by removing a window.
Ah, okay. Mm-hmm.
Magic delete key.
Yep.
Oh, look at that.
And
It's
bang.
gone.
Okay, it's gone. So now we can put a door in. Ah!
Oh, there's rib.
We just
What
had,
happened?
we just had Ron Marsh of Ron's Trains and Things show up. No worries about being late. We're still in the thick of things, Ron. So I think all is good. David is just demonstrating on how he designed, say, the side of a passenger car. Oh, and unfortunately, people are giving Ron a bit of a. I'm not sure if it's a hard time or a little bit of a razzing on the loss of his of Kansas City on Sunday. So.
Oh God.
But. And so now you're.
Well, what happened there was I went to do the subtract command.
Yep.
But you see, when I select the wall,
right,
the letterboard and the rivets don't light up,
right,
because they're separate pieces right now. So what I've done is I made 3 copies of the door, so I can go wall subtract. We're gonna have the wall subtract the door, and we have the lower and upper letterboard subtract the door, and then the rivets subtract the door, but I don't see the rivets, so I can't really do it. So there we go.
Okay, and so
we have rivets sitting there. Get rid of those.
Yep.
Oh. Undo.
Yep.
Undo. That's better.
There we are. Okay, and so now then with.
No, we got floaty rivets, right?
Right.
So I can come in.
Yeah, and so you don't want the floaty rivets, so you want. Okay.
Back.
Okay.
This is the way it goes, right?
Yep. Well, I mean, in part, it's like it's kind of these things is that you kind of learn along the way, and part of it is just trying to make sure that. Like for those of us who are just learning, this is all part of the learning process and experimenting with it. So, just in just a few short minutes, you've managed to create the side of a passenger car.
So far.
But you're now you're actually adding now you're adding something else. So
you need a door.
Mm-hmm.
Like the problem is the CPU is chugging away here with the connections.
Yep. So. Oh, Dodo Tops, what happened on Sunday is the Super Bowl. And Ron's favorite team, unfortunately, did not overcome, so anyway, that's I think as Ron said, it's like, okay, that's fine, let's move on to 3D printing, so that's what we're doing. So, Dave, while you're doing this, you have actually taken plans from various sources, including whether they're model railroader or archives that you can actually take an architectural plan and actually create something in your CAD program and print it. So, for example, if I were to find the actual plans of, say, the office of the Cape Breton Central Nova Scotia Railway, which is the one that I'm currently modeling or going to, a little nod to Andrew Underwood out there, that we could actually, if we found an actual architectural plan of that particular office, we could design it in a CAD program and print it, and it would be it would be accurate necessarily for our railroad. So you can actually take these archive plans that you would find in magazines and actually print something from them, rather than they were originally intended for scratch building, but now you can actually import them into a program like this and print.
Oh yeah.
Yeah.
So what we have here is, let's call this done.
Okay.
In terms of let's say this is the passenger car, and we say we're done. So we want to make a second side to it. So I'm going to do something called a union, which will basically glue all the parts together. So this is all one part now.
Mm-hmm.
All right. So we're going to, let's say for the sake of argument, this passenger car has sides are exactly the same.
Mm-hmm.
We're going to do a mirror command.
Okay.
And let's move them together,
mm-hmm.
so they're about 10 feet apart-ish.
Okay.
And then you can build a roof, you can build a floor. So let's do
mm-hmm.
I can do this quickly here.
Yeah. So now, Dave, as you're doing something like this, so you've now basically created the overall shape of a passenger car. You can go in and further detail it. Now, I've also noticed, particularly in for example the plow that you sent me, that you've broken them into different parts.
Yeah.
And I take it you do that. The thing that I did last week was my first structure, the very first structure that I ever made, the beehive burner, and I just did two. I just did it in two parts. But when I originally posted pictures of that, someone actually asked me, "Can you print that in G scale?" And of course, I designed it in N, and I was actually doing some math, and I realized that my big resin, my big FDM printer, my filament printer, actually is not big enough to print a beehive burner in that scale in G scale. So you would have to be cut. You would have to be enlarged and then cut into pieces.
Yes.
So, but I mean the other piece, and Eric Hall had already raised that, is he designs an HO and then he scales down to N. And the beauty about 3D printing is that you can generally grab any model that you can find on Thingiverse or wherever. And I mean, there are some things that you have to adjust, but in theory, you could grab them and just take them and shrink them down to whatever size you need.
You could, but the walls get thinner.
Yes,
the supports get thinner,
and so there's a hard limit. So
yeah,
you made the walls on that 1.5 mil, which.
So let's take this guy and let's scale it down to N scale.
Yeah.
Right. So we're gonna copy this.
Right.
Right beside.
Yeah.
What do you say? You said 50. 54.5.
54.5 from HO.
So there's the N scale version.
Right.
Of that.
Yeah.
Passenger siding. But you notice
the wall is of course going to be too thin.
Depends on the resin.
Yeah.
So that's now 0.9 mil.
Yeah. So
yeah, but also this, I don't know if people realize that this is a cutout on the back side of the passenger car for window glazing, right?
Yeah.
So I think this distance here is 0.5 mil.
Mm-hmm.
Yeah, it's 0.5 mil.
Yeah.
But now you've got a really, really thin profile here.
So putting it down
0.27 mil.
Yeah.
It gets pretty thin for some resins.
Yeah. So what you would do, like if you were doing this for N scale, you would shrink it down, and then you would kind of thicken that wall.
Yeah, so I'll do that right now. Actually.
Okay.
So what do we say? This is 0.9, right?
Mm-hmm.
So I want it to be 1.5.
Mm-hmm.
So I can select the wall. So
Okay.
I need to add 0.6 material to it.
Okay.
And this is 0.27. I want it to be 0.5.
Right.
So we need to find the spot there. So 0.27, 0.23.
Mm-hmm.
There.
And so now that would print
In N scale, just fine.
and print an N scale just properly. Okay.
Yeah. So these wall thicknesses are the same.
Yeah. So
right? But on the outside, that's still N scale, but you have, it's obviously a little bit deeper here for the windows.
Yeah.
The other option is to actually physically print this clear, in clear resin.
Yeah.
And you can give yourself a lip around the window and then mask it off and whatever.
Okay.
But the problem with the clear resin is it likes to yellow when you cure it. So if you have yellow windows, you're golden. If you don't want yellow windows, well, I think you need to use clear styrene or like a Mylar or something.
Okay.
So
good. So
that makes sense.
Makes perfect sense. Let's see. Eric just posted that he can also scale up to O and S scale from. Now, have you done anything larger than HO scale on some of the prints that you've done, David?
No, I've done HO and N.
Okay. Now, do you have one of your completed plows in the back?
You want? Oh, sure. I
Sure.
can do that.
Yeah, like it would be kind of neat to show that off. It just you'll just need to obviously stop the screen share so we can get it on nice big. So,
Yep.
But
no problem.
Yep. So. I've been aware of David's work for a while. He's fairly well known within the model railroading community in Calgary. But and of course, you've been doing scratch building for a long time, have you not?
Oh yeah.
Yeah. So.
Yeah. Stop share. There we go.
Okay. Now let me flip myself back up to just little and put you on speaker there. So and. People will be just a little bit behind in getting this. I just need to make sure that I've got my proper windows back open.
Can you see this?
Yeah. Can everybody see the plow? Now, of course, there are some.
Yeah. There we go. Yeah, it's showing up.
Okay, good. So if everybody can see, that's the CP Rail plow. And I feel lucky enough to get an Eastern version of that in N scale that I'm going to be working on, because there is actually one on the Cape Breton Central Nova Scotia Railway that is in pretty rough shape in the era that I'm modeling it, but it's still there.
I'm trying to show in the light here. You can see the rivet,
and you can see the rivet work on there.
I don't know how well that's coming through.
Okay, good. Ron just said that you can see it. You can see it fine. Now the decals on there. Did you custom design those yourself, or
the decals?
Yeah.
These are Bill at PDC. He made them for me.
Very nice.
I've got lots and lots of these CP Rail decals.
Okay.
But you can get the Canadian Pacific and Script and Block from Highball and Black Cat. And, yeah, they're more than available.
Yeah.
So this is a Prairie variant plow. So
yeah. Now here's
and there's brass on there and some plastic here and there. And,
very nicely done. And I mean, I think the beauty of this is that one of the things when it comes to 3D printing is that, like, as we said earlier in our broadcast is that we have I have the plow that you designed printed in front of me, and
yes.
it's a matter of trying to put it together. So,
that's not hard.
Yes,
I'm a modeler. I designed it to make life easy, not more difficult.
Yeah, it's good. Yeah, I'm looking at Eric's comment is that it looks really nice. Not sure it'd be useful in the Valley of Sun in Arizona. No, probably not. Mm-hmm. But they are actually. They're quite common. In fact, you drive past Red Deer in Alberta, and you get fairly close to one of the yards, and there is a plow within sight of the highway. That I think is one of these that's still in service, but I'm not sure.
Oh, yeah, well, they're in service all over the place. So they built these really well. They're not retired yet. Mm-hmm. There's that live cam from Revelstoke, and when it snows, you can see the plow train going back and forth, and they got the Western plows. Yep. One of these guys.
Yep. So okay, so it's that type of. So how many different plows have you designed?
Put me on the spot.
Oh, sorry.
Sorry, you got the ones based out of Nelson.
Yeah.
Which there's a Survivor at Harris Park.
Okay.
You've got the Western Standard Plow, which is this one. You got the Prairie Plow, which has got the extra plow on the high end there. Mm-hmm. And you've got one I call it the Banff variant with kind of a bump out. Mm-hmm. See if this will show up here.
Okay.
There's a bulge on the side. Can you see that, John?
Yeah, I can see
that. In focus?
Yeah.
The reason for that is it protects the wing. Let's see if this wing will actually work with this model. Mm-hmm. So they can shove the plow into the bank, and then coming backwards, it won't catch. Okay. The bulge protects the wing going backwards, right?
Okay.
And then I got two Eastern variants.
Okay.
Yeah.
And largely, of course. Well, I mean, CP Rail is your railway.
Yes.
So.
Is there any other questions out there?
Well, there was a little comment of the plows might be good for removing in Arizona would be good for removing sand from the rails.
Yeah, there you go.
Sand drifts, dunes. So with Eric here, do we have any other questions? I mean, largely we've been looking at general design and how what David's been able to do. So SD40-2?
Straight 40.
Okay. Oh, an SD40. Okay.
Yeah.
Okay.
So the nose piece is printed.
Okay.
See if I can. I gotta take that.
Mm.
You take the shell off, actually.
Okay.
So the nose was removed. This is the original Kato nose.
Okay.
And this is the CPR replacement one I designed. So you've got the dual pile headlight,
right,
as well as the brake wheel housing with the chain, which is different from the ratchet.
Okay.
And then the louvers aren't there.
Okay.
In the CPR prototype, right?
Okay.
So it's made to specifically replace that part that you cut off. Mm-hmm. Sorry, going down to the. It's always more difficult when you're live, right?
Oh yeah, of course it is.
and you can see the steps we saw earlier.
Yep.
As well as the rock pilot.
Mm-hmm.
And the cab also is printed.
Okay.
And I designed it to accept the stock window glazing from Cato.
Okay.
And of course, the number board is a separate piece as well, and that's my own bell and my own number boards and whatnot. And I've got a number of these things to build, and it makes building them a whole lot easier.
Oh yeah.
And the end as well,
mm-hmm.
right? It's a replacement piece. You can see what's been replaced and what's original, right?
Yeah.
So, and of course, you got the right profile in the back and whatnot. So,
and specifically, this isn't for someone else. This is for your railroad.
This is for me.
Yeah. Now, speaking of yours, and kind of flipping over from resin into FDM and into filament, because of course you just recently acquired one. Do you want to show off your turntable or I
can't specifically show up the turntable, but I can show the bridge and the deck.
Yes. So why don't we do that? Because David, in 3D printing for model railroading, the Facebook group, I think you have actually shared pictures of your actual turntable.
Yes, I have. Yeah.
Yeah. So if, I would recommend go check that out. But you actually have created. This is your.
So this is the bridge. It's hard to get all this in frame.
Yeah.
This is a. I've got the actual plans from the Canadian Historical Association, CPHA.
Mm-hmm.
And this is the actual profile for the bridge of the turntable at a Revelstoke. Mm. So the turntable itself has the right profile, which is something you can't buy. Walters doesn't make it. No one else makes it. The CMR doesn't make it. Bowser doesn't make it. It's very Canadian, very specific. So the core I printed in FDM. And the reason I use FDM is this is melted plastic. Mm. So when this comes off the build plate on the FDM printer, it's straight, it's true, it won't warp on you. Mm. It has a little bit of flex to it this way, but it's straight and true, and it'll always be straight and true. Now, when it comes to resin printing, I don't know if this shows up, you can see there's a slight warp on the end of the bogey. Mm. This bogey is resin printed. So with resin, as it cures and dries, it'll warp on you. But what you do is you just heat it up and bend it back into shape, and everything is fine.
Right.
The other thing is resin is very brittle.
Yep.
But it's very strong. It won't bend for you, right? So what I'm going to do is I'm going to make the girder for the side of this bridge out of resin. I'm going to skin the bridge with the girder detail. So you got rivets and girder and whatnot, and that'll strengthen the bridge up. Mm. And so it's kind of combining the two 3D printing types and give something that actually works on the layout. So, should I show you the bridge? That's the actual deck.
Sure, why not? Because you can show how really this is a multimedia piece.
So the deck has PC board ties, wood ties, Code 70 rail. These wood tie strips, I guess you'd call them. I don't know what you'd call that, but they came from microengineering bridge rail, right? And it's keyed to snap into the actual girder here. Mm-hmm. There you go, snapped in.
Okay.
Right, so that's it. And then this fits. There's on the actual pit is a pillow block that this sits on the pillow block, and then there's electrical connection, and it spins round and round happily, and service you as you see fit.
Yeah.
So why am I so nervous? I don't know. But yeah, it's new for me, and you know, combining the different printers to give you what you need for your layout. You know, it's one part is resin printed, the other part is FDM, and
Yep. Yeah.
wood ties and PC board ties and soldering and rail and gauging
and this goes back to an early question in terms of what is the best printer to get. Now, the question was specific to N scale, of course. And N scale, if you're doing detail parts and things like that, of course, resin is certainly the better way to go. But if you're doing structures or utility or things like that, that's when the filament printers come in. Like Ron, you're on this. I believe you created a bracket for is it for a tortoise switch motor? If you happen to be near the keyboard. Oh yes, and of course I have my son here, who's just popped in to say hi. Early on he I said he can drown out power tools, so I'll just make sure that he's aware of that. So I mean it's an example of there's a bunch of different things that we can be doing with 3D printing, and above all it's a matter of also being able, we can also share the stuff that we do. I mean I think it's still worthwhile making sure that people are adequately compensated for the work that they do to recognize that work, but the ease of being able to share that.
yes.
So okay, there's Ron's reply just came up. So it's an Arduino Nano and servo under the benchwork as a switch machine. So and that was something that he was able to do for his expanding layout as it comes up. So and of course my son is now beside me.
That's okay.
Yeah. So
I'm just putting into frame all these FDM parts that
yes.
I was able to print off.
Oh, sorry, Daddy. Oh.
Mm-hmm. David's trying to talk.
Okay.
So, nice.
I'm doing cold.
Now, at this point in time, I mean, we've been going for nearly an hour and a half. Do we have any other questions in terms of what people might have? I mean, you know, David, I am ecstatic that you were able to say that you were willing to do this.
Oh, it's my pleasure.
And
do they want to see the way things are formed in the different slicers?
You know, I think that would be that would be good. That would be good to do that.
Okay, hold on. This is
so.
So we need to screen share my. Are we already screen sharing?
No, we're not. We are not.
That camera.
We're not. It's just your camera. We're not currently screen sharing.
So why don't I? How do I unshare it?
So, just give me a moment here because my. So.
Now, how do I stop sharing my camera?
Oh,
that's you.
Yeah, that's me. Don't worry about that. You just share the screen, and I've just arranged it so that people see it. There we go.
We're on the screen now?
Yep, we're on the. I believe so, or will be shortly.
Okay.
Oops.
So let's find something that we can open up in both.
And as long as you're sharing your desktop, you should be okay.
Can you see my desktop?
Yeah, I'm getting it here. I think we're good.
Okay, so let's go back to the this pilot here. So we saw this before in the Tutu box.
Yeah, and so this slicing program is Cura.
Yeah, so we're just jumping back and forth here. I'm going to put them both to the same.
Yeah. And so this will give you an idea of the type of resolution that you can get with a resin printer versus what you can get with a filament printer, and why you would why one is certainly better than the user. Vincent, are you asking what slicing program he's using, or what design program that he's using? If it's a design program, he's currently using AutoCAD, but there are a lot of different design programs out there. All all of them have different strengths. I mean, AutoCAD certainly is the 800-pound gorilla in the room with that. But Fusion 360 is you have to go through a little bit of a process, but you can get Fusion 360, which is made by the same people that make AutoCAD, so there's some cross functionality there. So with that kind of, but whereas what he's using here are what are called slicing programs that take a 3D file, a STL file mostly, and translate it into a form that the printer itself will recognize. And Chitubox is the one for working with specifically the elegoo Mars, and I believe the Anycubic Photon also uses that. There's a few printers that use Chitubox, whereas the one you're using for your filament printer is the Cura one. And I actually have both of these because my FDM printer is also it uses Cura, and but it's actually specifically designed for the Lulzbot printer that I happen to have. So
I've taken the same part. We saw this before. The pilot. We talked about this before.
Yeah.
And I'm going to show you the difference between the two. So this is the MSLA printer, and you can see it actually does a layer at a time. So these pillars go up one layer at a time, and then it hits the bottom tread of steps. And you notice at this point we have individual, what would you call this? A safety tread on the bottom step, right? And you notice it's there for a few layers.
Yeah.
Right. Now if we go over to the Cura, right? And this is FDM.
Yeah. So and specifically, and this is specific to your so your version of Cura is specific to your printer, because Ron was noting that, and the Cura version that I've got is specific to my Lulzbot.
So you notice that detail's not there.
Yeah, there's just simply that detail isn't there at all. It won't even.
So what I'm going to do is actually go back here. We're going to switch to the highest quality this program will do.
Right.
Re-slice it, and then we'll see to give it a fair shot, right?
Yep.
Okay, so this is sliced at 1.2 mil.
Yep.
That detail doesn't exist.
It's still not. It's just simply still not there.
Still not there. If you go back to the Chitubox, so that detail is not there.
Yeah. Dad, look at his screen.
So even if I take this this piece and I scale it down to N scale, right? So now this is N scale.
Yep.
Slice it, and then watch. That detail's still there.
It is still there. I mean, of course, when you're slicing it down to so yeah, and
then I don't know how to scale. Let me try go to Cura and see if I can scale. How do I scale?
Yeah, you should be able to.
There we go.
You can scale in Cura as well.
There.
So
there, N scale,
and then you zoom right in, and
we're gonna slice it.
Yep.
Preview. Oh dear God.
Yeah.
What have I done?
Like even to the point where that actually would not print.
Yeah, because you got stuff in the air.
Yep. And
there's no way.
You would suddenly get like spaghetti. So I mean, there's an example. Yeah. So now, just in terms of things like, for example, there's also things like layer height. Like I think Eric just remarked that he tends to use 0.04 on his Anycubic photon for which his resin printer.
Okay, we can do that here.
Like, do you have a preferred layer height that you like to work with, or?
It's fine. In HO scale, 0.05 is fine.
Yeah, I think
I can go down to 0.01, but that just multiplies my build time by 5.
Yeah,
but I don't see really any benefit to HO scale for that.
Yeah, I think that's one where I think an N scale might benefit from.
But you look at what you printed there. I sent you the plow.
Yeah.
Now, when you put your finger over it, can you feel the rivets on the side?
Can I feel the rivets? Yes.
Yeah.
I can most certainly feel the rivets.
Well, then going down to smaller resolution is not going to help anything.
Yep. Yeah, I'm trying to see if I can actually see the layers. Unfortunately, my lighting in my room here isn't nearly as bright, so I need to get this and put some magnifiers on my head.
Yeah. But there you go. This is N scale, you know.
Yep. And so
you can even bring this down to Z scale. I don't know. Anyone know the ratio?
I would have
go down to.
Is there anybody out there that immediately knows what the percentage difference between HO and Z or Z scale happens to be? I can't say that there's a prize for someone who gets to it first, but.
So what's the math? Do you have to go X over 220? Is it 220?
Yeah, it's 220. It's 220.
X over 220 is equal to 1 over 87. So you go 220 divided by 87. Is that it?
Hang on. I think you have to invert that. Hang on. Try 0.40. For 40%.
40%?
Yeah, instead of 54%, try 40%. I could be wrong on that though.
I don't think it's 40%. Can't be.
Yeah. Yeah, no, I think you're right. Oh, we went way small.
Yeah, I know. I need the number for that scale.
Okay. All right.
X over 220 is equal to 1 over 80. So you need 220 divided by 87.
Okay. Well, 220 divided by 87 is 2.5, but 87 divided by 220, I can't remember that, is 0.397 or 0.398.
Here's 25%.
Yeah. So.
But here's 25% of HO. And you still get that detail.
Yeah.
Right?
Yeah.
But if I went to my settings and I changed the 0.1.
Yeah.
Slice it.
Yep. Make sure to change that back before the next time you print, though.
Yeah. This will take 2 hours and 1 minute to print.
Right.
But that detail is still there. We get 5 layers of that detail before it moves away from it. But that would print just fine.
Yep.
There's no problem there. The supports would be a little small. Like we get an idea of the size difference.
Yeah. And
compared to
yeah. And of course, Eric just raised a good point, is that as you do smaller layer height, you also have to adjust your exposure time.
Yes, of course.
Yeah. So, because of course,
look at that.
Yeah.
Make the HO scale look giant. Look at that.
And yeah. Well. Speaking as an N scaler, I find HO scale generally giant in the first place. But anyway.
Okay, let's not go there. Horribly oversized.
Yeah.
You've heard it all before.
Yeah. Well, I mean, kind of going the other way is to take potentially take it up to. You could do that and then take it up to O scale potentially.
Here's an orientation study.
Okay.
We got the cab and we got a roof for the cab, and notice the orientation of the roof. Now, why wouldn't I print this with the roof on the cab? It has everything to do with suction and what it does to the model as it prints. So if the roof was on the cab, as the printer worked its way up to where the cab went angled, it'll actually pull the sides of the model in, and you wouldn't have a true cab. It would be a little warped on the top, especially on the very top of the roof of the cab. So I got the roof orientated at 90 degrees and the cab orientated at 90 degrees. So this would print. It does print very well.
Yeah. Ron just confirmed my calculation. HO down to Z or Z scale is 0.39. So 39%.
Like that.
Yeah. So that would be Z scale. So. And the thing is that you can do that like right on the plate. I mean, there are, of course, as you've pointed out, the wall thickness and things like that are things that you have to do that. But say for example, you download an HO scale something from Thingiverse or wherever that you could, if you're an N scaler like me, you could shrink it down. Like as a matter of fact, on you showed pictures of acetylene tanks, right?
Of which?
You had some acetylene tanks?
Yes.
Yeah. So, well, actually, of course, this is a particular thing that is currently sitting on Thingiverse, and that's Bernie in Mittens. And Bernie in Mittens. And so you're going to show how you scaled him down to fit inside your HO scale car.
Yeah. So let me go down to open observation.
So figure it's trending, and somebody did that. So, okay, Ron, thank you for posting that. That's really helpful in terms of knowing what your ratios are. And so that allows us to kind of I think the beautiful part about this is that this allows us like usually. As various as an N scaler or an HO scale, O scale, we have a common thing in hobby, but generally we our ability to share is fairly siloed. Whereas in 3D printing, that's not necessarily the case. That we can actually share something that can be scaled to whatever scale we happen to be working in.
Oh, undo.
Oh, you scaled.
Bernie
needs to get scaled down, not the chair.
So he's got his foot on the ground.
Okay.
What?
And you just kind of move him to kind of fit on the chair.
Yeah.
Yeah.
I think he's still a little bit big.
Yeah. So
you can use.
Let's go 30, 32.
Yeah.
33 maybe.
Mm-hmm.
There.
Yeah. And there we go. And so if someone actually designs passengers, for example, for a passenger car, in HO scale, you can use this kind of idea to actually create passengers for your layout. I mean, probably if I were doing it, I would probably look ones that for designed in 1/48 or roughly O scale and shrink them down, because probably the sculpts on those are probably pretty precise.
Yes.
And go down from there, because I think. So now, can you tell people what you're doing right here?
We're adding supports, so we're pretending we're going to print this thing.
Mm-hmm.
So I got to support the lowest points, right? Because we want this guy to feed off of himself in terms of printing. So looking at Bernie's mitten here,
yeah,
you can see I'm trying to find the lowest point, which is right there.
Yeah, and so if you didn't support that, that would actually print sort of, kind of.
It wouldn't print. It would just fall off. It would end up on the build plate.
Well, that's just it. Is that it would cure in there, but it wouldn't be attached to anything, and so you've got a bit of cured resin floating around in the tank, which can mess up later prints.
So this looks like it's not supported, but it is. You see how when I raise this up, this is printing, this is printing, this is printing, this is printing. So it's not an island, right?
Yeah.
I'll show you this mitten here. So as I bring my cursor up here, you can see how the circle is created.
Yep.
That shows me that's not supported.
So therefore you would have to put a support there.
That's right. Yeah.
Okay.
So you just kind of go around, you find them.
Mm-hmm.
That one's fine.
Yep.
Yeah, there's Bernie.
Yep. And so so now you and say for example you want an army of Bernies.
A Bernie army.
Yeah.
I'm saving this file. I can delete it. Now I can open it up.
Yep.
So this is what we just created.
Yep. So now we've got one Bernie, and let's.
Now, do you want to play the count or should I? Two Bernies, three Bernies,
So imagine this as a a truck or as I've done an HVAC unit.
What?
That all of a sudden now you can actually print as many as you need, just like that. And the little thing about resin printing, for those people who already do this, you already know this. But with resin printing, it takes the same amount of time to print one as it does 50, as long as they fit on the plate. It's the exact same amount of time. So there is an efficiency in printing more of them. Yeah. All right.
Try to find something else people want to see here.
So, do we have any other questions for David as we go? Oh, well, there's
I call it the Coca Hall variant, but these worked out in Nelson.
Okay.
They had this extension on the top for the higher drifts.
Yep.
And we got one at Heritage Parks was able to actually have someone, Harvey Taverner, actually went and took pictures from the top. So this is the structure that exists at the top.
Oh.
Nice.
And he's got a specific. Yeah. Well, we won't dive into the other when stuff.
Well, I think one of the things with 3D printing, as we've already talked about, David, it has to do with this is a very deep rabbit hole.
Yes.
So, and honestly, we could probably go on for an extended period of time. Right, of course, the barrel.
55-gallon drum.
Yep.
So you can see how I supported it from the bottom.
Right.
So this support was all done in CAD. And I left a post on there so you can put this into a drill and you can paint the bands if you want.
Okay. So
does that make sense? And
yes.
Then, of course, you can print
as many as you want. So the idea is that you would actually print it. You would print it, prime it, and then put that small. That's like you would break off the small tile on the bottom of it, but put that into a pin vise and use that, and then be able to paint it.
What?
Pin vise? No, I'd use my Ryobi drill.
Oh, yeah.
It's a big enough post.
Okay.
Okay.
Now, when
here's something else. Hold on.
Okay.
Here's something else.
Okay.
That's a large window from my fan house.
Okay.
So that's the frame of the large window.
Okay.
She got me.
I think I have.
I got one in race. Oh.
Window all.
Okay.
There we go. And that's with the.
And so that basically, and that's a window frame for something that you scratch built.
Yes.
Yeah.
And you can see all the supports.
Mm-hmm.
It takes more time to add the supports than it does to print the bloody window.
Yeah, I would imagine, and it probably took you as much time to clip those off, but the payoff is worth it.
Yeah, because you got a window that's solid.
Yeah. Well, actually, as a matter of fact, did you want to go to big screen and you can actually show the model that you did that actually has that window in it?
Sure. Hold on.
Yeah.
So I have to close this.
Yeah, and so as David goes to get this, yeah, just simply stop your screen share, and then I will adjust things so that you're nice and big. And
I'll use this camera over here.
Yeah,
bear with me.
You might need the other. There we are, and because this is a big model. So what David has done here is he has created he's actually created a fan house that is one of the tunnels that goes underneath the Rogers Pass after they gave up with all the snow sheds going over top of the Rogers Pass. They basically just started drilling tunnels underneath it. And now, is that the fan house for? Which tunnel is that the fan house for?
Connaught Tunnel.
That's the Connaught Tunnel. And so the walls on that are styrene, but the windows are 3D printed. The air conditioner unit that's in there is 3D printed, and those big fans are all 3D printed. Correct?
Yeah, that's right. Yeah.
Okay. And of course those fans are like there is actually the shape of the fan inside those housings in there.
Oh yeah.
Yeah.
Oh yeah. They're in there.
Yes. So how many?
And they rotate.
Yeah. And how many parts?
For the fans?
Yes.
Lots. Actually, I go back to Chutubox. I can show you the actual file.
Yeah, and actually there's one question. For the window, why wouldn't you print that flat? And why the supports on the window?
Because the actual mullions between the windows. What do you call it? Yeah.
Yeah.
They're too fragile.
Okay.
They're 0.5 mil. It's a 0.5 mil square. It's the smallest I want to go with this resin.
Right.
And if I print it flat, all of that will have an elephant.
Right. So it'll be just a little bit too wide and a little mushy.
Yeah, it wouldn't look as sharp as this. This is quite sharp. So that's why I printed an angle.
Mm-hmm. Yeah.
It's yeah.
So you print it on the angle to make to get it to kind of get the detail out of it, because of course the first layer is when you print something on a resin printer, the exposure is 10 times somewhere around 10 times longer than it would normally be. Although in David's case, I just mindful that my son's near me. He used an expression that his stuff sticks. That he tends to overexpose his first layers to make sure that they stick to the build plate. And I mean, some of that's kind of your preference, but this is something that really works for David. Now, is that a tunnel portal?
Yeah, I'm gonna switch to a better camera here.
Okay.
But in the what's the name of the canyon? Can't think. Albert Canyon.
Yeah. There's
a whole bunch of CPR tunnels, and this is a particular tunnel. Let me change my camera. There we go.
Mm-hmm.
Right, so this tunnel is at a certain point in the canyon. I wanted to capture it, so there was a family that was having a vacation, and they actually sat on the top of the tunnel portal and took pictures. And that's the only way I have prototype photos of this thing.
Okay.
So once it's painted, you'll actually see the date right above my fingernail.
Okay.
It says 1912.
Nice.
But it's too small for the camera right now.
Right.
Once this is cleaned up and painted, all that detail will come out. But this is accurate to that tunnel portal. And I got a bunch of tunnel portals right now sitting on the layout, and they're all accurate to what they are and where they are. So.
And so now in the case, like you designed when you designed this, like you didn't have to redesign, like you could just work on variants in terms of size, or did you actually from the ground up design each one of these?
Well, I did a mirror image of them.
Yep.
So the other side is a mirror image of it, but you can't mirror image the date.
Right.
So I had to do the date again. But it's they're all pretty much standard. Like you got that single tunnel portal there, but over at Tree Valley Gap, you know, it originally was a double track.
Right.
So you have the double track portal.
Right. So it's even though there's a single track going through it, it's a wider track.
Yeah. So it's a double track portal, but in the steam days, this was double track.
Yeah.
So this is the same dimensions as the Connaught Tunnel entrance because the Connaught Tunnel had two tracks going through it.
Right. Now I'm just following up on a question from Steve87 PS. He just you make windows. So when David prints windows and doors, you tend to do them standing up with supports underneath it, so they're off of that initial print layer.
Yes. Yeah.
And in the case of the windows, you tend to angle them and then support the mullions so they'll print properly.
That's right. So it makes it easier to clip off the support that way.
Mm-hmm.
Right. If you think about it, if you have it on an angle, then you can get your nippers in there and easily nip them off.
Yeah.
You know, but if you have it printing 90 degrees for the build plate, then you have to have supports in between. It just really doesn't work well.
Yeah.
So windows are delicate things if you want them to scale out well. So you need to take the extra effort and angle them so they're easier to print and to remove the supports and whatnot.
Like for example, the windows that I've created as replacements for something that I'm currently working on, the mullions on it are oversized. I mean, the someone else has certainly noticed that. But I think part of it is you just kind of tailor it to whatever the needs of the model happen to be.
That's right.
So how many that tunnel portal? How many parts is that?
This one in the frame?
Yeah.
Well, you've got the wing.
Yeah.
Right. I put the brass piece in there.
Okay.
You got the liner is two parts.
Yep.
I don't know if it shows up 1, 2.
Okay.
And I believe the portal. Where'd I? Yeah, and the balance of the portal is another part. So it's 1, 2, 4 parts in this one.
Okay.
This guy here is also 4 parts. You got 2 for the liner and 2 for the portal itself.
Yeah.
So but that's mainly because of the limitations of my printer, right?
Right. Because of course you're doing the HO scale and the size. Like something like this could actually print one piece and in potentially.
Yes, and I've got an example of that.
Okay.
Let me. What am I doing right now? So I have to go. We're a camera, so I have to go to screen share. Share screen.
Well,
share.
If it's from your desktop, then yes. Oh, and I'm there. They're doubled up. Okay.
Am I good now?
Yep. We're in Cheetah Box.
All right. See if I can find this here.
Mm. Yeah. Now, there is a question in terms of,
So this is the east portal
right.
to the Connaught Tunnel, and it's a little bit big for the build plate.
Yeah.
So let me scale this down.
Mm-hmm.
20.
Okay, so that's even a little big for end scale.
John.
Barely.
John.
Interesting.
Right?
Yeah.
So let's try sending up.
Okay. Interesting. That'll fit.
That will print.
Yep.
Now the arch, I probably want to support it.
Mm-hmm.
That's just auto support. I would never use auto support.
Yeah.
I would go ahead and support it as I need it.
Yeah.
But that would print an end scale of one piece.
Right. And so that gives you an idea. Now, of course, you're in process because you work in HO. You want to try and get your hands on the elegoo Saturn.
Yes,
which
it's about 4 times the build plate of this guy.
And so you would be able to print like this in HO scale. So
yeah. But I'm not doing this. This east portal is for Nathan in Edmonton. He's modeling the Connaught Tunnel. So
right.
I actually designed this for him. So this is made from plans and photographs.
Okay.
So this will print quite well in end scale.
Yeah.
So
very very nice. The now here you were showing the tunnel like the tunnel liner piece. Tunnel liners would be something that an FDM printer could also do fairly well.
Yeah. So if I go to if we go back to just give me 1 second. I'm going to grab something off the layout.
Mm-hmm.
Bear with me.
Yeah.
Still here. I haven't left.
Yeah. There's also Eric's posted some good information. I do want to see if I can try and be successful in sharing Eric's pictures in a moment, because we shared them earlier and from my desktop and it didn't work. So okay.
So this is one portal from Eagle Pass.
Okay, David, if you can unshare and then make that big screen, because right now it's quite tiny. So stop your sharing and we'll put you up to camera. There we go.
Is it big? Okay.
Yeah.
So there's one of these portals. There are 3 tunnels at Eagle Pass, at Clan William, if you will. But this one is exposed. If you look at the prototype, this much of the tunnel portal is actually beyond the actual mountain itself.
Right.
So
right.
I hope that answers your question.
Yeah. No,
tunnel liners.
Yeah, I think so. I think so.
But you absolutely could print that on an FDM printer.
Yeah.
But you wouldn't get the nice smooth surface that you have here.
Yeah, but I mean, if it's a case of you want to actually do something more like a tunnel liner inside for the purposes of the structure inside of a layout.
You could. In terms of my prototype, this nice smooth liner only existed about that far into the actual mountain itself.
Okay.
And after that, it was just blasted rock.
Right.
So I probably would just use like a cardboard kind of frame and then go in with plaster and make it nice and rough in there.
Yeah.
But you could absolutely FDM print a tunnel liner if you wanted to. Sure.
So Eric just posted some helpful information, and yeah, he did share with me a link in terms of, you know, there's sort of different angles, and I mean a lot of this is that there's a science to it, but it's also there's a lot of art in terms of practice and what generally tends to work. I'm going to try and do the screen share of some of the stuff that Eric did that was unsuccessful earlier. Because I'm going to do the same thing that we did before. Is that I'm going to share my desktop because that seems to work a little bit better. Where are we here? Share the, okay, I'm going to share the desktop
Oh.
and see if nuts. People can't see it. Eric. I'm sorry. I can't make, for whatever reason, I can't make this work. That I've never had problems with this before because, of course, David, I'm assuming you can see this for a shared
Yes,
screen.
I can see it.
It's a Mac. I'm on a Macintosh, and there's certain permissions here. So anyway, I'm going to just stop that share. I'm glad it works on yours. I'm very glad it works on yours because it has made tonight work for us, and which I'm very glad to do. Now, time-wise, I'm looking at the time here, and we are sitting at
Bars.
yeah we've been at 2 hours here, realizing that we need to eat.
No, I already ate.
Thank you for the comment, Ian. So you may not need to eat, but I certainly do, and I imagine that David does as well. So we're just going to take a couple of last questions here.
Sure.
There is one question from Vincent Sanders to how do you glue printed parts together?
CA Smith.
Yeah, just standard CA.
Well, a butt joint, I would use thin CA, hold the parts together, and then micro brush capillary action, or bigger stuff, thick CA holds it together. But CA cement generally.
Yeah. Okay. Now, sort of similarly, one thing that I have actually tried on my end that works is for FDM, specific to FDM, not for resin, but for filament, PLA specifically. That I've actually tried the Plastrec orange bottle, which is basically methyl ethyl ketone. It's just straight up MAC. Works really well for doing PLA. And I'm that was sort of an experiment because I decided, oh, what the heck, I'll just try a couple of different things, and the I tried the Tamiya thin cement, which is my go-to cement for styrene models. Works for me. It works really well. But I also happen to have the Plastrec orange, the methyl ethyl ketone, and it worked really well. And just solvent dissolves it just enough and holds pieces together very nicely. So
don't use Gorilla Glue. Don't use Gorilla Glue. It gets bigger.
Yeah. What? And I actually that's something I think a lot of us N-scalers are well aware of. Does it expand?
Oh.
Yeah.
Oh God! I almost ruined my turntable with the Gorilla Glue.
Oh boy.
Yeah.
Yeah.
Don't use Gorilla Glue. I had no idea.
Yep.
Had no idea. You get one part wet, apply the glue, put
and then
together.
3 hours
came
later,
back a couple hours later,
and it will not come apart.
Oops.
Yep.
and I actually had to rip off the bottom layers of my turntable, but I managed to save it. But
yeah. Well, I mean,
don't use Gorilla Glue.
But I suppose if that's the case, you can also reprint. So
yeah, the turntable, it's a 100-foot turntable, and it prints in 4 quarters.
Yeah.
And each quarter takes about 9 hours.
Okay. Now there is a question from Ron Marsh about for thicker parts like the tunnel portals, would 2-part epoxy work?
Yeah. Yeah, sure. Yeah, epoxy doesn't expand, right?
Yeah.
And a lot of people, I don't use epoxy, but yeah, epoxy would be fine.
Yeah.
It wouldn't affect the nice thing about this resin, specifically the stuff I use, and I think it's generally the same throughout different manufacturers, is this stuff is immune to isopropyl alcohol, immune to acetone. It's just good stuff, right? So Yeah, an epoxy, no problem.
Yeah.
No problem.
Well, I mean,
sorry, before we move on,
yeah.
I need to clarify something. So part of the cleaning process with the resin I use, the Surya Fast, is you use, I use a dirty bath of IPA, 100%, and then a clean bath of IPA, 100%, and then water. And I remember about a year ago, I decided, you know what, I'm just going to let this freshly printed part just sit in the IPA overnight. What can happen to it?
Yeah.
Well, the next morning, it's a floppy little mess. It's no good.
Okay. So
I learned then that you can clean it, but don't let it sit.
Right. Okay.
Clean, but don't let it sit.
That is good to know. Is going back to epoxy. I actually used epoxy. I printed an airbrush stand, and the clamp on the desk, like the clamp, unfortunately didn't print properly on. And now this was PLA. Because this is just on my hobby desk and there's no way it was going to come off, I decided, you know what, I'm gonna put epoxy down, and secured it to my desk, and I just kind of used a regular clamp to hold it in place until it was dry, and it is rock solid. I mean, you know, I think it'll pull up wood before it comes off. So yeah. Gorilla Glue is the Viagra of glues.
Yeah.
Eric is not wrong there.
Yeah. No, absolutely right.
Yeah. So
I'll never use it again. Actually, it was a fresh bottle and it's in the garbage somewhere.
Yeah.
Yeah.
No,
because I figure if I keep it in the basement, you know, in a year or so, I will have forgotten how it works and use it on something else, and then it'll ruin another thing. It's like it goes away. Doesn't work. It goes away. Doesn't stay in the basement.
Yeah, that's probably a good idea.
Yeah.
So a lot of the questions have been really good tonight. And David, thank you so much for being here. I apologize to the audience out there that I all things considered, considering that this guy here can drown out power tools, he's been not too bad. Isn't that right, Ian?
Yeah.
So
you're right about that. And if I do this, well, I'm taking pressure now on there on Toy Spark.
He's a 6-year-old and he's a ham. Now, that having been said, as the engineer for my layout downstairs, he's pretty decent as long as he listens to the conductor.
Yeah.
I actually have a video on that coming up. We actually filmed an ops session where he was actually the engineer, and I was sort of
the conductor
moving him. So that it seemed to be fairly it worked. So,
but I can get John 1 second. If I can get a plug-in before we forget,
please do.
I have a Facebook group. I forget what it's called. I think it's CAD Ninja. Was it something? Oh, but anyway, you have to search my name. I've got a swag ton of files on my computer.
Okay.
And these files are available to people except for major files like the dynamometer car, the plows.
Right.
But detail parts and signals and whatnot, shoot me an email, send me a private message, and we can, if something you would like, let me know.
Okay.
Happy to share it with you.
So David, actually, if that works, like for those of you who are on the YouTube page, you've got the contact me. Contact me, and I'll hook you up with David for those files.
Yep.
And of course, these are for personal, non-commercial use.
Yeah, don't sell them.
Yeah, please don't. But thank you so much for being on, and thank you for the plow.
Good luck.
Yeah,
print it though.
Yeah, well, I mean, it did print some of the parts, unfortunately, because I was just trying to get all on the plate and print it off before tonight. Some of the parts failed, so I need to figure out, okay, which ones succeeded, which ones failed, why did they fail? Because I'm still fairly used to this. I don't know if people can necessarily see this, but these are both resin printed. These are both from a water washable type, and this is the elegoo water washable ceramic gray. This is pretty decent. This, on the other hand, is it's frozen, and it's a lot more pliable. You can actually feel it. Whereas this one's rock solid. But if you look really closely at the base of this one, notice all the warping that happened here. Over the past week, David has been working with me to try and get my benchy to print properly, and so that is I want to say a special thank you that David really is a guru with this, and I think as for the potential for model railroading of opening up this world to all of us. Just as a quick question to you, David, if you're interested in doing another show in terms of maybe we do something a little more topic specific for 3D printing rather than just kind of this broad general thing. If people are interested in another chat, I'm certainly glad to do that. Maybe there's some questions for those of us who are just starting to get into it. I would love to have you back.
Sure, I'm happy to do it.
All right.
Absolutely.
Anyway, with that, I think everybody is just. I think we need to wind this down. We are now 2 hours and 10 minutes into this, and so it is time. I think time that we sign off. And thank you so much for everybody for sticking around, because it's 9:40 Eastern time for those of us who stayed up so late. So thank you very much. And
thank you, John, for hosting this.
And thank you so much for being on, David. We will talk soon and do some more follow up, and then maybe plan another 3D printing with Dave.
Sure, sounds great.
Okay, great. Anyway, and of course, if people are interested, email me, and I'll kick your email over to David. You'll find my email in the contact part of the YouTube channel. For those of you who are either watching this live or if you're catching this on a later show, or if you're doing this on rewatch. So, and for everybody who missed tonight, don't worry. This as soon as I stop this is now you can go back and watch any segment of this that you like, and that's the beauty of how all this has come together. So. Again, thank you very much. And so, David, if you want to stick on for a little bit, I'm just going to bring the stream to a close. And again, thank you very much.
Bye.